Okay, we're going to test the pressure vacuum breaker. This is our 1-inch Combraco pressure vacuum breaker. The flow is going vertical. We have our shutoff valve number 1, test cock number 1, test cock number 2, the air inlet, and shutoff valve number 2. Then beside us we have our gauge is a Midwest 830. We use these because they're easily identifiable which valves are where. My low as well as vent bypass hose are both rolled up. I do have my high side hose available. I've already removed the canopy off of the assembly. I've already told the customer we're cutting the water off, and now I can flush. So I'll flush the test cocks. No particular order. My test adapters are already in. Once I have flushed the assembly, I can now take my high side hose and attach it to test cock number 2. When I get that connected, all I have to do is open test cock 2, fill my gauge. I'm going to bleed it off, removing any air from the system. So I finished bleeding. At this point, I'm going to reach up. I'm going to close my shutoff valve number 2. At which time I can then isolate the assembly with shutoff valve number 1. I can record my line pressure, which is roughly 98 psi currently. The assembly is completely isolated. I'm going to make the air inlet open. To do that, I have to remove the water that's holding it closed currently. I have my hose attached here, so easiest thing to do is reach over here and grab the high side bleed. Just crack it open a little bit, not too much. And the needle's going to start to fall. I'm going to hold my finger on top so it can help me identify when it opens. I'm watching the gauge. It opened at 2.0 psi. That's good. The air inlet is fully open. I can see right down inside of there. Alright, so the air inlet's working properly. I would record 2.0. Close my test cock back up. Re-energize the assembly. After that, I can now test the check valve. When I test the check valve in the pressure vacuum breaker, it's going to be pretty much like the double check valve. I am going to measure the water that's trapped on the front side of the check, and there should be 0 pressure on the back side of the check. So what I'll do is hook my high side hose to test cock number 1 like I have. I will then pressurize it and bleed it off. Finished bleeding, I will shut it back off. Now my gauge is filled. I have the water in front of the check. I can now isolate the assembly once again. At this time, my gauge is topped out at 15, which means I'm still holding pressure in here. So what I'll do is reach the test cock number 2, which is on the back side of the check valve. Open it up, moving all of the water out of the assembly beyond the check valve. I'm looking at test cock number 2 to make sure the water has ceased to flow. Got a little residual drainage here, but it should stop. There it goes. I will now look at my gauge and get my differential, which is 1.4. If the water did not stop running out of a test cock number 2, I would have had to take in my bleed valve arrangement, and I would have had to have attached it to test cock number 1 and then my high side hose on it, and that would have allowed me to drain the excess leakage coming from shutoff valve number 1. But it's not the case. Shutoff valve number 1 is working properly. Now, since this assembly can't be in an installation where back pressure is present, we are going to check for back pressure. So what we'll do is reach up to shutoff number 2, slowly open it, and see if there's pressurized water coming out of test cock 2. Since we do not see that water coming out, no flow occurred at all, we know that there is no back pressure downstream of this assembly. So we can now close shutoff valve number 2 back up, at which time we can now close our test cocks, remove our hose, slowly repressurize the assembly. Then we will slowly repressurize the downstream pipe. And that completes the test of the pressure vacuum breaker.